Okay, I'm going to try and jump back into the rest of these and go a little bit quicker now that we talked about kind of a lot of that background there. Right now, the other video is uploading onto YouTube, but it's being super obnoxious and it's taking a little bit of a while, so you'll get it. So back to what we were talking about. Next problem is asking us to find the length of KM. So, like we've been saying, so that way we don't do a Miss Davis and cross through that circle, let's go ahead and follow along exactly what it wants us to find and pull out a pencil here, and we're going to be looking for KM's arc length. Okay. So I can see here that this is going to be a major arc because it's not a semicircle, because if it was a semicircle, it would have just been J, N, M, or J, K, L, M, like that. So let's figure out what we need to do to find this arc length. Up here, we can figure out what this half is and figure out what we're missing here. And those are my notes here. Let me go back when I solved it. What I did was I went ahead and found out what this angle right here was, because I already knew this was 21 and I knew this is 90 because I've got my nice little here little L square straight edge look. I can't even remember what you call that, 9-degree, symbol. So I know this is 90 degrees. This is 21, and I'm missing this one. And right here, our circle is broken completely in half, so I know this whole side here is going to equal 180 degrees. So what I did was, I did 21 plus 90 plus x, that one we're missing that we don't know, equals 180. Okay, so 21 plus 90. Look, I keep getting rid of my calculator too. Get back up here. 21 plus 90. I'm using a calculator because I really don't want to mess up. 111. All right, so we've got 111. Okay, let's get an extra space here so we don't confuse ourselves. 111. These two right here equal to 111 plus x, carry down that x there, don't forget, equals 180. And now we're going to solve just like a regular algebra equation. So we are going to take away 111 from this side, and then we are going to move over here onto the other side of our equal sign, and we're going to take away 111 from this side. Alright, so what have we ended up with here? We have ended up with that green line. That is so obnoxious. Who wants a green line? Alright, let's see what it equals. So, you guys are going to cancel out here. Alright, get out of here. And if it's green, it could just stay green. You can go away. We don't need you. You crossed out. 111 minus 111 is 0, so you're gone. And now we need to figure out, so 180 minus 111. 180 minus 111 equals 69. So, x equals 69. Okay, 69. So I know that this angle right here is 69 degrees. And I'm going to go ahead and copy this text box and just, really? Really? You going to play with me like that? Copy. Paste. Get over here. This one right here is 69 degrees. Alright, 69 degrees. So, let's just make sure, just to see, 90 plus 69 plus 21 equals 180 degrees. We're cool. So that's 180 degrees. So, if you look right here, Abby, look where it is divided directly in half again. So we know that this M to N to J is 180 degrees. So that's going to help us here. So, all we need to do is we're going to put this arc length here, this M to N to J, this 180 degrees, okay? And it gave us this one right here. It said it's 21 degrees, so that we can make it the rest of the way up here to K. So we are going to do plus 21 degrees, okay? Oops, go back. Equals, let's see, 180 plus 21 equals 201. Okay? Okay. Now, if we went that way, this right here should equal 201. Let's make sure that we're correct. Okay, so we have 201. 201 plus 69 plus 90 equals 360 degrees. However, we could also figure out what K to M is going the other way. So let's get rid of this line here. And let's figure out what the arc length of K to M is this way. So we get a pencil. So K to M going this way, let's see what this side of the arc length is. So this side of the arc length, we don't need this 21 here because that is K to J. So we have K to M. We need 69 plus 90. Okay? Plus 90 equals 159 degrees. Okay, 159 degrees. So there's a couple of options there, depending on what way your teacher wants you to be finding this arc length of KM. And that's where I am a little bit unsure myself. But let's just make sure that that is going to equal 360 degrees in every way possible. So we have found this arc length here, which is this one right here, the 159 degrees. So if this is 159 degrees, and then we added in this 21, we are at 180. Awesome. And we can see right here that J to N to M equals 180 because it's the rest of their semicircle there, plus 180. We're at 360 degrees. So it's just going to depend on which way it is that she wants you to be going to be finding this arc length of KM. Not exactly sure, looking at your problem, how she wants you to be going about that. Perhaps sometimes I know with these online courses that there'll be multiple correct answers, depending on how you look at it. And it does not give us a dark arc where it's like shaded saying exactly which way they want you to go. So my suggestion would be to do this one here, this K to M going this way, since they gave you this 21 degrees up here, and this 90 degrees, that perhaps this is the side that she's looking for to see this arc length, not the K to M going on the major arc. I think she's looking more for the minor arc. So that's my suggestion, is I would go ahead and try this minor arc here going this way. Okay? And then if it ends up saying that it's wrong, and if it gives you an opportunity to try again, then you can try, okay, well, let me see the arc length of K to M going this way for the major arc. Okay? So, next problem. Now we're here. Find the length of the arc length of VYW. Alright, let's get out my pencil so I don't mess this up like usual. Pencil. VYW. Okay, here I can see directly which way I need to go. Because if I tried to do VYW, I would cross through my circle. And I learned not to do that. So, V all the way around to Y, all the way around to W, and we stop. And if you notice, look at that right here. It already gave us this arc length right here of 23 degrees. So this seems to be the easiest problem that she has given you. Okay, so we know that our entire circle is going to be how many? 360 degrees. So we're going to do 360 degrees minus 23 equals 337 degrees. 337 degrees. If you're curious, by the way, to do that degree symbol on the computer, you hold down Alt and then use the numbers 0176 if you ever have to put in a degree symbol. Fun fact for you. Alright, so VYW's arc length, 337, okay? And we can check it. We always want to check it. Always want to check it. So right here, I can see that I have 67 degrees here. This is broken in half right here. This is 23 degrees. If I have 180, $157. So this one right there would be 157. Shoot. 157. I'm not doing the degree symbol. 157. 157 plus 23 equals 180. Alright, we're good. We're golden. Okay, so now over here we have 67 degrees and we have 23 degrees. That's 90. But we have two missing areas here, so this is where we're getting a little bit crazy. Let's see here. Let's try... Ah! I know, Abby. I see it. I know what to do. Oh, it finished processing. Here, look, next. Let me get this up for you. Yes, it's made for kids. Next. And I'm going to send this to you in like 2 seconds. I don't care about ending an end screen. And I'm going to send you this link so you can watch this video. That's the first half of your little video there. Copy my video link. Okay, so I'll send that to you in just a little bit. Okay. And let me pause that. Pause. Okay, so go back. Where are you? Where's that cool thing that I found? Alright. That's where we were talking about the adjacent congruent arcs. Okay, so let's see here. Let's go back to this PowerPoint. So, right here we have 23 degrees. So let's see if we can pop this 23 degrees over here. Alright. Nope. I still don't feel correct about that. How about 157? It is right. Okay, so this is 23 degrees right here. So what I did was, I looked at my circle differently here, where it was in half right here. Here's my 157. I know this half of my circle is 180. So what I did was, 180 minus 157 equals 23. And I was correct that these adjacent congruent angles here are going to be the same. So I am going to turn my circle back first and put my 23 in there. Insert text box. Let's put my 23. Alright, so that's 23. Okay, so now I have almost a whole circle. So let's see what we're missing. Let's add up what we have so far. So far, starting right here, we have got 23 plus 157 plus 23 plus 67. Oops. 67 equals 270 degrees. Okay? So all of these equal 270 degrees. And we don't know this one. Okay, so that's our x. So we're going to say 270 degrees plus x equals 360. Our whole circle always equals 360 degrees. We only got this one last one that's missing. So we can just solve this like a normal algebra problem. Take away 270 from this side. And then we are going to come over here and we are going to take away 270 from this side. Okay, and then let's get out my silly green pencil. You go away. And our final answer. Why, Abby, tell me how to permanently make this a black line. It's so obnoxious. I don't want this green pen. All right, 360 minus 270. Let's see. It is 90. I guess it feels confusing to me because I don't see my 90-degree symbol, but I'm going to put it in there and I'm going to see and I'm going to double check. $90. Abby, can you think of a couple of ways that we can double check to make sure that that should be 90? I think maybe if we did, okay, this side right here should equal 90 degrees, shouldn't it? 67 plus 23, does that equal 90? It does. 90 plus 90 equals 180 plus 23, right over here, plus my 157. Okay, I've got 360 degrees altogether. So I know that my answer is correct for my arc length of VYW. V, and I went all the way around to W, so it was a major arc. And my answer, let me make it bigger because I did all this other stuff. My answer is 337 degrees. The length of VYW is 337 degrees. Nope, just you. Okay? So that's how we're going to find that one. Next one. This looks like crazy, just crazy business. It's insane. But it's really not that difficult. It's not as difficult as it seems. So, for this one, turn my page. What I did was, I saw my 124 here. And then I saw my 3x minus 1. And I saw that my circle was divided in half right here. Made it a semicircle. Okay? So, I know that my semicircle, this half of my circle, equals how much? 180. I feel like Dora. How much? 180 degrees. So, I'm going to add this all together, this stuff that I have available for me right here on this side of my circle, to equal 180 degrees. So, here we go. So far, I have 3x minus 1 plus 124 equals 180 degrees. So, first thing I'm going to do is, I don't really need this parentheses because I'm doing any multiplying here. The only multiplying that I'm doing here is this 3 times x, which we're just going to leave, you know, together anyways. So, let's get this bigger here for you. What I need to do is combine my like things. So, minus 1. Okay, so 124 minus 1. Abby, was I really going to pull out the calculator for that? I was. 124 minus 1, we've got 123. Okay, and then we've got our 3x. Now this 3x can be on either side, because I know it's over here, but if you notice, it is a positive number because you do not have a negative sign in front of that 3. So I can say 123 plus 3x, or if I felt so desired, I can say 3x plus 123. Okay? So, all of that equals 180. Now, just like usual, and I'm not going to type it all out because we've been doing it and I know you know how to solve an algebra equation. What we're going to do is we're going to take away 123 from both sides. So that 123 would go away like we've been doing, just like up here, it'll go away. Which one was I on? Where are you? That 123 would go away, so I need to do 180 minus 123. 180 minus 123 equals 57. So now I have 57. Let me get that 3x in front just to keep it the same because I think that's best. Plus 57. Excuse me, not plus. Equals 57. Because you know what? Look, I'm going to have to do it anyways. Minus 123. See, this is why we should always show our work. Because every time I don't show every single step of my work, I mess up. Every time. So I need to just go ahead and show my work. Alright, as much as I don't want to. Okay, so 180 minus 123 ended up equaling 57. So now, all we have left is that 3 times x. So to get rid of that, we know that we are multiplying here, so to get rid of that 3, we need to divide. So we are going to divide everything by 3. If I divide 3 divided by 3, you know we're going to get 1. So that means I'm going to be left with just this x equals, and then I am going to divide by 3 right here underneath this 57. Divided by, do you like that? Divided by 3. Let's see what 57 divided by 3 equals. 19. X equals 19. Okay, now you know we got to check it, because what if I did something wrong, which is very quite possible. So we're going to plug that 19 into where x is to see what we come up with. So if we have 3x minus 1, x we have is 19. So 3x minus 1. We have 3 times 19, okay, minus 1 equals, and let's see, 3 times 19 is 57, which we should have known that because we just did that there. 57, and then minus 1, we have 56. Okay, so 56. So this right here is 56 degrees. Right? Let me check my notes. What did I do differently? I have something different. 57. Divided by 3. X equals 19. No, okay, I'm good. I guess I just didn't check my work. Alright, so that's going to be 56 degrees right here, because we plugged in what we had for x. So let's just go and change it. Let's just get rid of it. So we know this is 56 degrees. 56 degrees, right there. Getting nice and close. 56 degrees, 124 degrees. It's completely divided in half, so we know it should equal 180. Let's check. So 124 plus 56 equals 180 degrees. We have found the value of x. Now, 56 is not our answer. The only reason that we ended up, figuring out this 56 here was just to double check our work. Because the question is, find the value of x. Because our original problem had said 3x minus 1. Good gravy. 3x minus 1 over here. And it didn't necessarily want to know what this arc length was here in degrees, but it wanted to know what x equals. So this was our answer. But we were smart and we went ahead and plugged it in to make sure that we were correct. So there's that one. This one, you're going to be doing almost the exact same thing. I think you can try this one on your own. Okay? I know it looks a little bit crazier because it has more numbers in it than this one. But you're going to follow the same steps, Addie. Okay? So you need to look and see what you already have in your circle. Let's see. We know we 100% have this 47 degrees. We know we 100% have 90 degrees here because we have that 90 degree symbol. So to help you out, we'll put that 90 degrees there just to remind you. Here's 90 degrees. We have 90 degrees. And keep making my text boxes so small. 90 degrees. Okay? So we've got 90 degrees right here. Alright? And then we have this 10 times x, and then we have 9x minus 5. So, remember, if we have angles right across from each other that share a connecting point, where was that? That was in these notes over here. Here we go. They have the same measure. Okay, they have exactly 1 point in common. This angle right here and this angle right here have exactly 1 point in common, right there in that middle. So, if this is 90 degrees, I point with my finger as if you know. If this is 90 degrees, then this 9x minus 5 should be equal to 90 degrees. And you can solve for x. And then, after you solve for x, you can say, well, let me plug it in over here and see if it's going to end up being the correct situation once we add up all of our degrees. Okay? Now, let's see what I got for x here myself. Okay. I also did it another way that I didn't see here. I went ahead and said to myself, I guess, that I was just going to add everything up and combine my like terms. And I didn't think about, there's lots of different ways. That's what's really cool about math. Yes, there's only one answer, but there's lots of different ways you can go about it. So we already know that our whole circle equals 360 degrees, and that's the way I solved it. So what I did was, I plugged in everything that I knew, like this 10x plus 9x minus 5 plus 47 plus 90 equals 360 degrees. Because I knew my whole circle equals 360 degrees. So that's what I actually did on my own paper when I solved this problem. So that's two options that I gave you here. You could try and think about, your congruent angles there, or you can try and think about, how much it equals all together and try and solve it that way. But you always, 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 after you think you've solved for x, plug it into everywhere in that circle and make sure that it works so that it ends up equaling 360 degrees. So, I know I said all that stuff before, but this might be a good method for you. Make sure that you look at these things that are the same and combine your like terms. Right here you've got 10x and 9x. You can combine that together, add those together, and see, what you come up with. All these right here, you can combine together. So that way you can break your problem down smaller, right? So I'm going to let you do that one on your own, okay? And I'm going to see if you can figure out what x equals. Remember, when you plug in your answer, they're not looking for what your angles end up being. They want to know what x equals. They don't care what this actual degrees is over here. They just want to know what x is going to equal, okay, for your whole problem. Next, find the length of the dark arc. Find the length of the dark arc. Now, let me see what time limit I'm at here because I might need to stop. Yes, I'm going to go ahead and stop because this is where things get crazy business, okay? And it's not that crazy, but it's a totally different subject that you're moving on to. You're still talking about arc length, but this is where you're going to start talking about arc length and, whether or not you need to be changing things into radians, or if you're going to go ahead and use the formula that they offer you to find arc length when you are offered with degrees. Lots of different options. I will explain them, and then you will be able to do this one on your own. This one you can totally do on your own, Abby, because you have done all these other problems with me where it asks you to find the arc length of PQ. You can find that. I know you can. It's very right there, just saying. And then this one right here says if JL, so you look, you've got JL, your diameter is 50. You're going to find the arc length of LM, okay? And I want to see if you can solve that one on your own. And if you can't, or if you have any questions, contact me and I will try and help you. Or if you end up getting a wrong answer, let me know what it says, and then I will see what I can do to assist you further. But I want you to be able to solve some of these on your own, because I don't want to give you every single solitary answer. So do what you will with all of this, and I think you're going to be really successful. You can go back, rewatch, go back, like if you are struggling with something, and just rewind your video and find those portions that you think are going to help you, like the reminders about what the arcs are, or these examples right here where we were talking and it was showing us what a minor arc is, what a major arc is, what a semicircle is. Think about my mistakes that I told you I made when I accidentally crossed through my circle like a crazy person. Make sure that you're going completely around your circle in the way that they ask you to. You're going from PST. If I tried to go PST this way, I would go through my circle. Absolutely not. I'd go around, okay? Take that information and use it, Abby. I know you can do this, okay? Let me know how it goes, and let me know if you have any other questions.